Goedemorgen allemaal. Good morning, my name is Kris Verlaenen. I'm the gBPM project lead, and I'll be giving a presentation on what I call process-driven applications. So first of all, a quick introduction. So I'm the gBPM project lead at Red Hat, JBoss. So for those that are not familiar with gBPM, that's an open source BPM engine, so business processes and everything related to that. So I basically focus, and my team focuses on developing tools, engines, whatever you need to work with business processes. A lot of the things that I'll be talking about are not really specific to gBPM. So a lot of the things are probably applicable to BPM in general, but obviously I'll be giving examples, etc., using our project. Just to make sure. I'm not going to give a very long explanation about what BPM is, what the advantages are, and all the technical features that our engine has, for example. I mean, this kind of technology has existed for a long time. Probably all of you know what it is and have seen a presentation either from another vendor or from our project already that lists all these things, and maybe you even have experience with it. But just to make sure we're all talking about the same thing, this talk is going to focus on business processes. So it's going to use the typical flow chart. So this is a very simple example. The key idea is you're going to extract some of your business logic. So basically you're writing applications and you need to do something. You're going to try and extract some of that into a flow chart, a higher level representation of your business logic. And that has a lot of potential advantages. I'm not going to say that if you start using it, you'll have all of these advantages. It depends on how you use it. But one of the typical examples is, well, that's visibility. I mean, you're going to specify in a graphical way the different steps you need to take. These are typically long-lived, so it's not that you do all of them at the same time, but you do one now and you do maybe the next one a week later. And there's other people that might be involved in your process as well. And by modeling it this way, rather than writing application code, obviously it's much easier to see what your process is trying to do. But it also makes it much easier to monitor it, because at the runtime, when you're executing one of these processes, you can obviously easily see, okay, I'm currently at that node or at these nodes. You could be at multiple nodes at the same time, and I'm waiting, for example, for my managers to give some input before this process can move forward. A third aspect is that business processes are a different level than writing code. So when you're writing code, you're using, for example, when you're writing code in Java, you're on Java objects. These are implemented, so they have a lot of properties, etc. That they could be fairly low level. When you're talking about business processes, you're actually at a different level. You could be using concepts that are at a higher level, that are specific to your domain, and that are much easier to understand than these lower level implementation objects that you might be using in the end. So in a business process, even though we might be invoking a web service with an XML schema and whatever, at the process level, we try to avoid that. So we try to hide a lot of the implementation details that might be hidden underneath. And then one of the key reasons why you want to do this as well is you want to continuously improve. And in a business process engine always allows you to update your processes. You have your business logic. Your logic changes due to whatever circumstances, and you need to update your process. You can do that, and then you can figure out what to do with your running processes. Either keep them running on the older version, migrate them to newer versions, etc. But it gives you the possibility to evolve without necessarily having to rewrite a lot of code. I mean, if you have to go to a code release that takes 3 months to update your business logic, that might be too late. It might be a business process might allow you to do changes that are almost immediate. I mean, you still need to have the necessary safeguards. You don't want to just go into production and throw out a new version without having it thoroughly tested. But it's a separate life cycle from your application code itself. And finally, I'll get back to that later in the presentation. It gives you also some benefits on agility, etc., to model more complex things that might be difficult in normal programming languages. And just to emphasize, BPM is not just about having an engine that executes processes. There's an entire life cycle around it, from the authoring, where you create the processes, and the execution, all the way through the monitoring and figuring out what's happening at runtime, and then improving your processes. So it's not just an execution engine. I mean, maybe 10 years ago, you could call yourself a BPM engine or a workflow engine at that point. If you only had a powerful engine that could execute these processes, nowadays you need actually an entire tool chain to support your users to model these things. And so the presentation I'm going to do today is going to focus on what I call process-driven applications. So while BPM is actually a technology, and you can just look at it as a technology you can use, obviously your goal when you're developing something is to build your application, and you're going to try and use technology that will help you with that. And in the past, I think BPM might have been more focused on just the technology itself and less on helping you solve exactly the problem that you wanted to solve. So process-driven application is actually looking slightly different at how you use BPM and trying to help you develop your application. And I'll explain you why in the last few years we've actually evolved to something where we believe we can actually start doing this now. And I'll zoom in on four things where I believe we've evolved. And actually, the evolution is all about we want to give you more. We want to give you more building blocks so it's easier for you to do whatever you need to do. I looked up my slides from Devoxx in 2008. I had a university session here then. I went through the slides, and it's very clear that at that point in time, we were talking about different things than what I'm going to be talking about now. In 2008, I did a talk about integration of processes, rules, and event processing, and how the technology could actually combine all these different paradigms into one engine. So you can see that actually at that point, the major themes that we were talking about were at a very low technical level, how you can actually combine these technologies. They weren't necessarily about building applications that you could use. So I'll start with these evolutions, and the first one is how basically BPM evolved from what, at least our project, evolved from being a framework to a tool. So our strengths, I mean, the project itself started as a process engine, so a core process engine, and it's still there. I mean, the process engine itself is a very stable, very performant, very lightweight engine you can use anywhere. And it's got all the features you think it should have. I mean, a process needs to be persistent, it needs to participate in transactions, it needs to be performant, it needs to be scalable, etc. So basically all process engines, all process projects out there, they have a core engine like that. I mean, for example, I mean, the gBPM process engine, just to show that it's lightweight, I actually have it running on my Android phone. That lightweight it actually is. And you can scale it. You can have just one engine for very simple applications, or you can expand it and have it in large data centers running thousands and thousands of sessions in parallel. So that's how it all started. We were really focusing on, okay, you've got a process, you design it, how can I execute it? What came next is basically a standard, the BPM2 standard that typically now all vendors implement. It actually helped because before all engines had their own language. Nowadays, the BPM2 standardized language that all vendors support to model your processes. It helped a lot. with the learning curve. It helps with interoperability between tools, etc. And implementing that on top of an existing core engine, well, it wasn't a huge amount of effort. Basically, it's an extension basically on how you save your processes in a specific format. But we kept adding things on top of that. So I already mentioned that the talk I did in 2008 was about, well, you don't necessarily only have processes. There's different paradigms that have similar goals. For example, business rules also allow you to extract business logic, but in a different format. So business rules are when-then format. And complex event processing is then about processing a high volume of events. And actually, if you combine these three paradigms in one, you actually have a very powerful solution where you can decide how to, or pick whatever technology is best to solve part of your problem and combine all of them to solve your entire problem. Okay, and then next, well, if you're executing your processes, etc., and your rules, the next thing was, okay, I want to figure out what's going on. People were expecting process management tools to be available, so we introduced the process management console, or basically extended it because it's been there for a while, but people were expecting more and more to have out-of-the-box tools to monitor these engines, etc. On top of that, for the actual modeling of the processes, you have a graphical process designer. So, I mean, I showed you a very simple flowchart. You can model your processes that way. But that's just one part of the problem. Your problem is typically bigger than that. It involves data. Data you may need to define as well. So we introduced things like a data modeler, a form modeler. So you're solving problems. Other people have to participate in that. They typically do that through a form. You can generate forms based on your process and show these forms to your end user. So these forms also need to be designed. So we introduced a graphical form modeler. Then BAM, so business activity monitoring or reporting. You need to be able to generate higher level reports about the current status of all your processes, etc. So that's additional tooling that was introduced as well. On top of that, then the cloud came. That kind of changed, or is still changing, the way we deploy applications and the scale we deploy them at. So then concepts like BPM pass and a process execution server. Because the core engine at the beginning, it's a simple Java purchase. You can embed it in your application and talk to it directly. If you want more loose coupling, there's what nowadays called a process execution server. So that allows you to basically set up a server and you can send requests to it, and it scales automatically. So you don't have to worry about embedding it in your project anymore. You can set it up once, and you can have a very scalable distribution. It does have advantages and disadvantages. I'll get back to that in a second as well. But as you can see, we keep adding more and more building blocks that you can use. Obviously, it depends on your requirements whether you want to use them or not. I mean, we have a lot of users, a lot of customers saying like, well, yeah, you, for example, have like a BAM tool. I mean, but we have our own, and that's typically fine. I mean, this is all an open source business, an open source project. We only give you the choice of having these building blocks, but we don't want to enforce anything. For example, if you go to a big company and say like, well, we've got a process engine, and we've also got this human task service to manage all your tasks and your forms, etc. They might say like, well, that's cool, but we already have that. I mean, we've developed our own. We don't want to use yours, and that's absolutely fine. So we have a building block, a process, a human task service. You can use that. If you're not interested, if you have your own, you can easily integrate with your own. But we want to try and give you all the necessary building blocks, and that leads to what I call process-driven application development. So this is one of the evolutions that led to that. We're actually giving more and more building blocks for you to consume if you want to. The second is there's an evolution from what I call embedded execution towards more as a service. So if you look at how people typically were using process engines, at least our process engine in the past, is that, well, you develop an application, the engine itself is a Java Pojo, you can integrate it inside your own application, it's just a few jars you include, and then you can deploy that application, and it's a very developer-oriented way of interacting with the engine. So basically, it's got an API. You've got a ton of operations you can call, and you can integrate at that level. There's persistence. You can integrate at the transaction level, etc. And it typically scales with your application. So you build your application, you deploy it somewhere. If you deploy it on multiple servers, basically the engine is typically deployed on that server as well. So it kind of scales with your application because it's embedded inside. Nowadays, especially as soon as you start thinking about more loosely coupling various services, people are interested in having more a process engine as a service. So it's basically the engine is there, you can deploy processes to it, and then you can interact with it. It's a completely different deployment model, and it's got different advantages. It's got also disadvantages. Thinking, for example, about fault tolerance or transactions, etc. Those are typically more difficult to achieve if you do it as a service, but especially if you're developing an application where your application is just fairly simple, but at some point you need to trigger a process to make it move forward or to start a new one. Having that process engine available through a remote API is actually very easy. You just do a REST call. You don't have to integrate with the engine inside your application, etc. And there's a lot of different architectures in between, but what you can say is that actually there's much more choice nowadays on how you want to deploy this. I have actually two examples of what we call typical architectures that we see nowadays, and one is what I call, we're going to scale as a service, so we're going to offer a process execution as a service, and we want to scale that. Then typically you set up your process engine on multiple servers in a clustered environment, and you deploy your projects to that. If you do it in a symmetric way, that's typically you have fairly powerful servers, and you distribute your requests among those servers. And each of the servers is capable of executing all requests. So assume I have 2 projects. I basically deploy them to all my servers. Whenever the request comes in, it's randomly distributed, so you distribute your load, and they're capable of executing all requests. This works very well, but it means that actually it requires resources from the servers because there could be hundreds and hundreds of projects deployed. But they all can collaborate. There's synchronization with a database, which is shown as one database, but also that could be that's a logical database. It could be distributed as well, of course. A different architecture is what we call an asymmetric scaling. It's the same setup, but basically you deploy empty process execution server, and you can control where you deploy your projects. This is something that if you hear the term micro architectures and stuff like that, people are thinking about these deployments rather than these other, a big server where all your processes run that really doesn't fit with the micro architecture. There you actually can deploy small projects, either to just do one server and you have a custom API you can direct to it, or you can deploy, you can control how you deploy your projects. So they give you a lot of choice in defining the architecture and how you want to set up the engine and use it. The third evolution is about as I mentioned, business processes are at a different level, and that's important because they're not only targeting developers. I mean, there might be processes that you develop that are purely for your developers. I mean, end users or more business users, they never see those. They're just running the back end. It's just your DevOps that might be looking into those. But there are also processes that are relevant for other people, for people that might not understand all the lower level technology that you might be using. And by avoiding all these implementation details in your processes and using higher level constructs, you can actually have them participate. Note that I'm not saying that we believe you can get rid of all your developers and have your business users all of a sudden implement all the logic themselves, because implementing an executable process with all the data passing, integration with external services, etc., is still a fairly complex problem. But they can participate, they can look at the results, they can possibly update in a constrained environment, etc., and they can understand the end result. And the first part, and this is a very simple example of the healthcare domain, even though, for example, you have let's say you have in a hospital, you have a service where you can actually prescribe medication, which might be a web service or a REST service or whatever. We're going to hide that. We're going to create a medication service. We're going to create a nursing task. We're going to create a notification task. So when you're designing your process, you're talking about, well, a nurse needs to do this task. I need to prescribe medication. I need to send some notifications. You're not talking about these lower level concepts. So we want to reach more people, not just the developers. I mean, if you have developer-centric needs, that's fine. We have an engine. You can embed it. You can use it. But we want to appeal also to these other users, to the business analysts for defining this, but also to the end users. Because I mentioned people might be participating in the process. You might have to look at the task list. You might have to perform certain tasks. There are forms involved, etc. So we want end users to also participate in this process, and we want to have tools that they can use for this. And to be able to do that, and that's the fourth evolution, customization is actually very important. If you look at the tools we have, and I'll give a small demo showing some of the tools later, but if you look at the tools, they are generic. I mean, you can define any kind of process, you can start any kind of process, you can monitor any kind of process, etc. Because we don't know about your domain, the tools we offer are also what we call generic. But a generic tool isn't necessarily very appealing to the end user. This is a screenshot where you can, for example, look at all your running process instances. So all the ones that are currently running, you can have a list of these, but it doesn't necessarily mean anything to an end user. It shows details, and some of the details might be very important. For example, it might show variables or documents related to this process instance, but again, it's very generic. It doesn't focus on the things that you find important in your process typically. We allow you to create custom filters so you can easily find the process instances you need, but even then, customization is very important. If you want to have something that you can offer to end users, that they will need to use on a day-to-day basis, you need to create something that is very useful for them, almost custom-made. Another example is the monitoring. So we have a web tool where you can define these charts, different kinds of reporting about how many instances are currently running and how many tasks are currently available. And we have what we call our default process dashboard. So that's like a dashboard where an administrator can go and look like, okay, these are all my running instances, etc. Again, this is a very, very generic thing and has only limited usefulness because it just shows a fairly technical overview of what you're doing. So what we recommend is, rather than using these generic dashboards, create your own. So create a dashboard that shows what you want to show. If you're processing orders, rather than just looking at, okay, there are 30 orders that are currently being processed, you can look at, okay, this is the amount of, this is the volume that's coming in, this is the average order amount that's coming in, the times orders might be coming in, etc. You can really create customized reports that show the data that you need to show. So we believe that's absolutely important if you want to offer these kind of tools to end users, that you're able to customize them to your situation. So by having more building blocks for you to use, by offering more choice on how you want to use the engine or the tools we have, by trying to get as much people involved as possible, and by giving you the opportunity to customize those tools, we want to help you develop your application. And that's what I call process-driven applications. You're starting with an idea that you need to solve a certain business problem, and you want to use a process engine for that. So your business logic is a sequence of steps, for example, and you want to start using the process engine for that. But you want to quickly get to an application that you can start using. In a lot of cases, a lot of the applications that are developed, or a lot of the processes that are developed, aren't necessarily that complex. There are not 100 people involved and 1,000 steps to be done. Usually just a few steps that need to be done, but they need to be controlled. So that's why you need a process engine. But by having a lot of out-of-the-box building blocks, and being able to quickly combine them together, you can quickly go from nothing to a prototype that shows what your application might be able to do. And we give you the choice and the flexibility to do what you need. You might start with something simple, and at some point you can, for example, say like, well, now we need to develop our custom UI for this. So we're going to replace the UI that we started with. We're going to make it much more complex, and we're going to fine-tune it completely. That's fine. You can evolve. So you can start with something simple and evolve. I have the impression that nowadays, being able to quickly show that you're capable of, or starting with a simple application, is extremely important. Applications will evolve, and you will then at that point need to figure out how you're going to scale them or how you're going to customize them. But getting to a point where you can actually show what the application is going to do and what benefits you get is extremely important, because the company might not be willing to fund an application if it takes 2 months just to figure out whether the application itself is going to be a success or not. So this is about this building block that I said that we're offering, and this is what we see as a very typical setup. If you're basically just interested in having a process engine to execute your processes, but you just want to interact with them. You have your own UIs, you just want to develop them, so you set up a process server that you can use. Either you embed it in your application or you use it as a service, but the typical architecture there is, well, there's an operating system and an application server. You can choose, and then on top of that, there's multiple engines that are deployed. Well, there's actually just one engine capable of executing all these different paradigms, but then you implement your logic as a combination of processes, rules, and complex event processing, for example. And there's a lot of other services that are necessary to make it all work. Think about timer services, because there might be timers related in your process, so they need to be a scalable distributed timer service there. Asynchronous jobs. Your engine is typically executing a lot of things, so we have what we call a job queue, where you can just put things in the queue. They're executed also in a distributed fashion. Obviously, persistence and transactions. If your engine goes down, your servers go down. You need to make sure you're always in a consistent state. And yeah, you might start on one server, you might continue on the other one, etc. So these are almost like the minimal set of building blocks that you need to be able to execute simple and fairly complex processes. And you can expose that through a remote API. So nowadays, in our project, we have just a simple REST API, but also a JMS API, which is very useful if you're looking for transactions. JMS actually it gives you much more value in that respect than REST does. Web service integration, a Java API where you can just that you can use to talk to a remote engine, EGB integration, etc. So we want to make it easy for you to just integrate with the process engine that is deployed somewhere from another application. Now this is then almost like the minimal set of building blocks that you can use out of the box, but you can go much more complex. And if you look closely, so this combination of blocks, this is actually this block here. So you could say like, well, this is the process engine for execution of my processes, but I actually want to use more. I want to use a web authoring tool to define these processes, and I want to use the BAM capabilities that we have as well, and then a web-based management console, which I'll demo in a second, that actually combines all of this. So this is almost like, well, if you want to use all the whistles and bells, you can pick whatever building blocks you want to use. Obviously, you can see I had fun in building this example for you, but my kids even had more fun. But it kind of shows like we have a lot of building blocks, and which one you use is up to you. You can use the full stack, or you can just focus on the specific things you have. And so I'll show you an example. So this is what we call our Workbench, or it's a web-based management console that tries to help you through the lifecycle of the process. So as you can see, there's we try to kind of show the different life cycles. You author your processes, etc. You deploy them to a server. In this case, there's just a server running next to the web application that will execute your processes. You can start processes and look at running instances. You can look at your task list, and finally you can get an overview of the current status, reporting, dashboards, etc. So in this specific, so if you want to develop, well, let's say a process-driven application, you typically start with a process, and I just created a very simple process here. So an expense process where you submit your expenses. There's some validation that needs to happen. Your manager needs to approve that, and depending on whatever you submitted, there might be additional approval necessary as well. And there's finally, there's sometimes there's a receipt check, so you have to send in receipts that actually verify whether your expenses are valid. And at any point in time, the reporter itself, so the person sending in the expenses, might be notified, etc. And so all of these three are human tasks. You can actually see by the icon here. They are a person that needs to perform a certain task. The first one is what's called a script task. It's done automatically. Or you could, for example, use business rules to do some validation as well if you want to externalize some of that logic. So this is one part then that you start with. In this case, I'm not using any specific data models. So the process is actually just gonna take a document as input, which it's just an Excel file, a spreadsheet that you send in that lists all the expense items. So there's no additional data that I need to define, but I did define a form for submitting for starting the process, so for submitting expenses. Actually, it's auto-generated because the process knows there's a document involved and there's a justification that needs to be provided whenever you start a process. So we automatically generated a form. The first one is just a document selector. So what it does is it allows you to select a file from your file system that will then be uploaded as part of the process. And then you can actually see that it's being bound to a process variable. So in the process, I actually have a variable document that will keep track of the expense document that I submitted. So this one is actually being used then in the process to move the expenses through the system, so that whenever I send my manager, for example, I request approval from the manager, I obviously send the document link as well, so they can go and look at the expenses as well. So this fairly simple process, just a sequence of a few steps, allows you to then, I mean, this is a project that I can now deploy and execute. So I don't need, I mean, there's a few details hidden, obviously, about, for example, here, I can see like this is to anyone in the program manager group can claim these tasks. So that's details hidden that I'm not gonna go show all. But I made this an executable process with a sequence of a few steps, and I can deploy this process now to my server. So if I look, there's, okay, it's the last one here. So I created just the first version 1.0 of the expense process, and this is deployed to the server. So you can go and look at, okay, what are my process definition list? So these are all the processes that are currently deployed in the instance that I have running here. You can see that this version of the process, I can actually start a new instance by, let's say, uploading this expenses file, giving in a justification, and then I can look at the details of this specific instance. So you can see actually validation was successful in this case, so that now it's going to wait for my manager, which might, I mean, depending on how you integrate the task service, might have an email notification that there's a new request. He might go and look at his task list and take a look and approve or deny the expense. What I've shown here is what I call this very generic tooling. So, I mean, you've shown a process list where there's a number of processes. You can look at, these are my running instances. You can just have a list. There's currently, for example, there's 3 expense processes. 3 expense processes that are currently running. You can look at all the details, but this is very generic, very low level. And I don't expect that as an end user, this would be the ideal tool for you to use. So what we allow you to do, rather than having to rely on this UI to do all the work, we allow you to create what we call then domain-specific extensions to our tool. And obviously you can just build your own UI, completely new, and integrate with it. But just to show how it's actually fairly easy to just create a simple screen that's much more usable, much more specific to your application. We have a component that allows you to define custom screens. And in this case, it's a very simple Angular application that will, in this case, will list all the expenses that I have currently running. So if you look at the code at the top here, there's the HTML, which is basically just a table in this case, where I'm going to show data related to the expenses that are currently running. A button, you might have buttons, I mean, this is currently just a table with a button, but you can make it slightly more complex as well. And so the Angular application, well, it's calling the controller. And what this is actually doing is it's calling our existing remote API. So it's going through REST. I'm not sure whether you're all able to read this, but it's basically calling the REST API history process and then expense process. So it's going to get all the expense processes from the audit tables that we have, and then you'll be able to, using Angular, I'm going to render this in a simple table. So this very simple screen, you can to be able to use that. You basically, by refreshing the application, you can make it accept new screens that you just defined. So whenever I refresh the application, it's going to look, okay, there's a new application, and it might be able to use that. So to be able to access this screen that I just defined, I'm going to create a new entry in the menu that I have on the top. So I'm going to create a new dynamic menu item, which I'm going to call expenses. And then I'm going to link to the view that I just created, the screen plugin, which is called expenses list. Okay, so I add this new menu item to the application. And if I now refresh the application again, there's a new entry here, which, if I call it, is currently listing the expense reports that are currently active. So what this shows is actually it's very easy to, rather than having a very generic table with process instances, you can show data which is very relevant. In this case, I'm basically interested in the amount of, in the number of expenses that I currently have, and typically the time they were started, for example, so you can easily see there, and you can easily add additional buttons to go look in more detail or like look at the expense file itself. But it allows you to create custom applications as part of our Workbench that are much more tailored to the problem you're trying to solve. To give another example, there's something what we call a perspective. So a perspective is basically a combination of multiple components to create a one view. So in this case, we have three types of components that you can use and combine into one perspective. The first one is an HTML component, and I just used one here. So this is basically just a simple HTML. I'm linking to an existing image. And you can use the screen component. So whenever you develop a screen, like I just did, you can combine them and pick and choose them, for example. Pick any of the existing components that we currently have and combine them. And then finally, we have what we call the displayer component. This is for the business activity monitoring and the reporting. You can create small views that show relevant information for your application. So for example, if I want to show the amount of expense items that I currently have access, that I currently have active, I can create a meter which basically just looks at all the expense processes that I have, which is a data set that I predefined, but I can just look at the count, so the number that I have, and customize some additional properties like, let's say, as long as I don't have more than 10, it's fine. And 20 is basically the limit that you would have. So you can easily create a custom graph that shows this kind of information, or a similar one that, let's say, we want to show the time where when the expenses were submitted, for example, per month. So just count the amount, and then let me just get rid of the legend here. So in this case, because I basically just demoed it. There's 3 expenses that were started this month. So if I save this, you can actually go and look at these perspectives, and they're dynamically updated. So you can create a custom page where you can, for example, list the expenses you currently have, get a few charts that show information related to that, allow you to submit expenses through that application, etc. So rather than using the generic tooling, you can easily create a custom page, a custom app that is focusing on the problem that you're trying to solve. Now, finally, there's one other thing that I like to mention, and that is also a final evolution, which is what's called flexible and adaptive. So one of the key concern that people might have when they're trying to use a BPM engine is that, well, it's actually, I have to implement my logic and I have to follow it. There's no way to adapt. There's always exceptions. There's always, I might not want to do this now, or I want to do something else as well. Can I do this? And in the past, if you look at traditional workflow engines, they were very strict. You define a process, you needed to follow that. You first do A, then do B, then do C. There was no way to skip B or to do D. You just had to follow the process as defined. Now, that's obviously useful if you want to have this kind of structure, but in a lot of cases, you might want a lot more flexibility. And then there's a lot of different terms you can use. In the past, we've called it flexible processes. It's called adaptive case management as well nowadays, or at least some people refer to this as adaptive case management. So what you need from your process engine is the ability to be able to choose. So you need to be able to model something where the process doesn't necessarily define what needs to happen, but there's someone else. When I was at the university, I worked on a company that did healthcare applications, and if you go to a hospital and you can say like, well, we want to help you in defining these kind of processes for treatment of patients, the first thing they will always tell you is like, well, that's fine, but it's the doctor that needs to decide. So you need to give people the choice in these kind of processes to, for example, do something even though the process is recommending to do something else. And there's also, in these cases, there's a lot of need to more advanced concepts that aren't available in, for example, the BPM 2 standard for defining processes. There's concepts missing that are absolutely necessary to do these more advanced cases, to model these and to execute these. For example, the concept of a case file where you can just drop data in and collect data for the certain case. The concept of roles, like people are participating in a process. In a lot of cases, it's very important to know who you're participating with. The patients that's relevant for this process, the different doctors, the different nurses that are participating. It's very important to define these. If you don't have a very structured process, you might be working with milestones rather than to track the state of your process or your case, rather than the traditional process instance view that I showed earlier. To give you an example, the BPM 2 spec does allow you to add a lot of concepts on top of the predefined concept. So the approach that we've taken is we have added quite a few additional features on top of the engine that we have to start supporting these more advanced cases. This is the healthcare example that I was referring to. And as you can see, the process itself isn't completely well structured. And there's basically 3 process fragments, as we call them, that are floating around inside these ad hoc subprocesses. So this ad hoc subprocess allows, rather than the process engine to define whatever needs to happen, it allows others to define this. In this case, there might be a physician which is looking, okay, these are the potential tasks that I might need to consider. Which of these do I actually want to execute? But there's also the possibility to combine this with other paradigms to automatically trigger, for example, some of these. So in this case, I might, for example, say that the blood pressure measurement on the top is something that always needs to happen if, for example, the patient is older than 50 and has we have data in his medical record that shows he might have these kinds of he might have some symptoms that might indicate some problems. So we're able to, for example, have end users decide what happens, have processes or complex event processing decide which of these would happen. And on top of that, you can actually add new tasks inside this subprocess, even though they're not even defined in the process. So if at runtime the physician is looking at the patient data and he sees like, well, actually that's, I see a problem here, I actually want to do an additional test, he can add this one. He can add an additional test to this ad hoc subprocess, even though it might not even be defined in the process at all. So these kinds of capabilities allow you to model much more adaptive cases. And in this case, it's still a fairly structured process, and the adaptive or the ad hoc part is just limited to these 3. But if you go to the extreme, you could start a case without even having a process at all. So you can start a new case. There's nothing predefined. You can start adding tasks to it. So like say, okay, I want to do this. I'm going to add a few documents. Then I'm going to create a task for one of my team members. He needs to go and look at this. And there's nothing predefined. And you can that's the other extreme. But there's a lot of in between. So from our point of view, case management and structured processes are what we call a spectrum. You can go the entire extreme and not defining anything up front and just doing everything ad hoc, or you could have a very well-structured process. But there's no distinction. There's no clear line in between. So the technology we offer allows you to model all of these using the same technology, same engine to execute all that. And then finally, and now I have to, I'll show a quick demo on how you can actually combine then what I just shown before, the custom app, with this case management. So let me quickly add a few services. So what I want to show is to be able to give a physician then the choice to keep track of these, or for example, to use the concept of milestones if you want to follow a patient through different milestones and have a view that actually shows how a patient is going through the different milestones. You can also create then these custom applications that will be much more useful for, let's say, a physician or for whoever's looking at using your tool. So the application was redeployed. So if I go in, there's a simple case management process that I have, and also a set of screens that were developed to accompany this. So similar to the example I showed before, this is a page that is going to show a table with all the cases that are currently running and their state. In this case, the state is going to be a little bit more complex, and it's going to have a few buttons, etc., to interact with the case as well, and some logic to go and get the information from the backend services. So if I go and look at the case management view in this case, you can fairly easily create something which is very specific to your process. So in this case, the cases are doing the treatment of my patients. I can see, okay, these are the cases that are currently running for these patients, and these are the tests that are currently still outstanding. And you can go and zoom in on the details. So this is a custom screen that shows that these tests are currently waiting to be submitted. And this kind of flexibility of being able to have choice, for example, we added a simple button here where the physician is able to choose, for example, okay, these are the options that I currently have. You could add a button to dynamically add additional tests that might not be predefined, but that's not developed as part of this demo. But as you can see, these kinds of views, these custom views that you can easily create, are, from our perspective, much more appealing and much more closer to the problem you're trying to solve. So to conclude, we believe that for process-driven applications, we want to help you develop your application. And that means, and I know that a lot of people are not going to use all the building blocks that we have. And that's fine. We want to give you the choice. If depending on what you want to do, maybe you just want to create a quick prototype, then you probably want to depend on a lot of the building blocks. Maybe you just want to, in the end, if you want to build a lot of custom processes in your company, you might end up building some custom UIs yourself, and you might not rely, for example, on the task list because you already have an existing UI to do this kind of functionality. So if you want to get started with this, so the gBPM project homepage probably gives you the links to everything you need. The latest version currently available is 6.3, which is, well, basically the one that I've been demoing. If you want to get started, the easiest is probably the installer, or you can just use a Docker image to get the environment that I've shown here. And the product, I mean, Red Hat offers professional support for this as part of the jBPM suite. You can actually get a developer copy of that as well. And if you have any questions, yeah, just contact us. I'll be available the rest of the day, probably at the Red Hat booth most of the time, or just talk to me whenever you see me. And we still have a few minutes left for questions, so if anyone has questions, feel free to ask.
Okay. Can you give some references who is actually using this product?
There are, so I'm not sure how many, so we have a few public references. And then depending on, I mean, if you're interested, our sales organization can provide references. We have, especially in the US, a lot of the big banks are using this as part of their portfolio. Not all of them have public references. Yeah, I'm not sure how many of these I'm able to reference as public references. So I think on the website a few of them are listed, but I don't have them at the top of my head at this point. Yes?
Are these templates, are they stored in a database or in Git or somewhere?
Okay, so the backend that we use for storing the processes and the data models, the forms, etc., is Git based. So you actually have access. So we have both web-based tooling and Eclipse-based tooling. I mean, it's not limited to Eclipse, but through any IDE, you can go into the repository, basically import the assets that are there. You can do modifications and push these changes back up as well. But the backend is Git, which gives a lot of additional features like I mean, different branches and version control, going back to different previous versions, etc. as well. So we rely on Git for that, and yeah, have many of the benefits that Git provides out of the box as well.
You don't have to use the interface to build these custom
Yeah, absolutely. So the frame, I mean, the web tooling that we have, we call it the Uberfire project. So that's just a generic workbench where you can combine these different screens. And we just have a very simple one where you can build these kind of Angular applications, but you can build your own screen and embed them, or vice versa. You can build your own UI and embed some of our screens. We want to give that kind of flexibility. I just showed how you can do it within the tool. It's mostly for demo purposes. You typically are not gonna develop your UIs through that. So typically you can just develop your application, communicate through the remote API, and then integrate it with your application, either within our application or just build your own application yourself. Yes.
When you develop an application from scratch and you want to do it with the business process modeling, where do you put what do you put in your business process layer and what do you keep on the lower layer?
Yeah, so that depends a little bit of what you're trying to achieve with your process. So my recommendation would be, like, if you're going to try and model a process that you're going to try and get end users involved and maybe business analysts participating in the definition of the process, you definitely want to try and keep the implementation details out of your process as much as possible. So for some of the more technical stuff, you might basically set up a service that does that and then have your process interact with that service so you can hide some of the complexity. In some situations, you might just want to define straight-through processes for development. In that case, having low-level concepts or implementation details in your processes might not necessarily be a bad thing. So it depends on what you want to achieve. But in general, what we recommend is try to define the process at the level of the problem that you're trying to solve. So try to define the concepts at that level, define all the data you need to solve that problem, and then have your process manipulate the data and typically also invoke additional services. So as soon as you try to do too many complex things inside your process, you might want to consider splitting that off either as a separate process or splitting it off as a service that basically is able to provide you that, so that the process that you're defining can be kept relatively simple, but some of the complexities can be hidden in a service, which you might want to implement or you might want to define in a process as well. All right, any further questions? I don't think I see any, so thank you all.